My dear student, now we move to the internal structure of the earth. The internal structure of the earth. Okay. What do we mean by internal structure of the earth? Actually, we are referring to from where we always stand downward to the inner part. Now imagine we are all living on the earth's surface. All our economic activities are taking place on the earth's surface. Now imagine, ask yourself, what took place that made people discover the internal structure of the earth? It is by different methods, by drilling, and some by using seismic waves, by assessing the velocity of earthquakes. Of course, this is done by man. They were able to trace that internally the earth is in different layers. And therefore, on this sect, we will be able to know that the earth is in different layers. And how do these layers behave? What are the components of these layers? And what should we do in order not to damage one layer after another? So, internally, the earth is with 3 layers. Layers of the earth's internal structure. The first layer, as they came up with, is the crust, the earth's crust, or lithosphere. The second is the mantle, or mesosphere. And the last one is the core, or bathysphere. Bathysphere. Therefore, from where we are downward, the earth is in 3 layers. We have the crust, we have the mantle, and we have the core. To start with the crust. The crust. Some are calling this is the outermost layer. Outermost layer of the earth. This is where all activities are taking place. That extends from 8 to 50 kilometers deep. Imagine it is 8 to 50 kilometers deep. Therefore, we consider this as the outermost layer, the layer that is with different materials, rocks, soil, trees, all living things are all within this layer. But this layer is so huge, as you can see. It's from 8 to 50 kilometers deep. But within this layer, there are also different other layers within this that we have. The upper crust and the lower crust. Lower crust. What does this mean by the upper crust? This is the layer which is composed of rocks rich in silica. Rocks rich in silica and aluminium. In brief, this is made of soil. These are right rocks. The rocks that are making part of the continent. Silica and aluminium. With the density of 2.65 to 2.70 grams cc's. And therefore, when we speak of continents, Africa, Asia, and other continents, mainly they are made of They are made of silica and aluminum. But again, the lower layer that we speak now is made of silica and magnesium, with a density of 2.9 grams per cc. Therefore, as you can see, as the uppermost layer of the earth, we have the cyolic layer, that is silica and aluminum, and we have silica and magnesium. Silica and magnesium are heavier rocks. Actually, these are what make the part of the ocean floor. And that's why the ocean is on the lower land. Why? Because the rocks making these are of silica and magnesium, and that's why they subsided, making part of the basin. But silica and aluminum are very light. That's why they were uplifted into the continents. And this layer, this crust, is alternatively called continental crust. Continental crust. Therefore, what we do in our daily life affects this layer at most. It is this layer that's endowed with a lot of minerals. So all shaft mining, all agricultural activities are all taking place in this. Therefore, it is this layer that possesses soil. It is this layer that supports all macro and microorganisms. And therefore, we need not to litter the earth's crust. Otherwise, we endanger all kind of life. The second layer, as we have seen, is the mantle. It is the mantle. What is the mantle? This is the second layer. This is the second layer of the earth. It extends from 50 kilometers to kilometers deep. The first layer started from 8 to about 50 kilometers. Now this extends from this to this one. Imagine how long is that? How deep is this? If you were to travel covering these kilometers, imagine on the surface of the earth, where could you have traveled to? From Tanzania here. Something that you cannot imagine. And again, on this, the rocks have the density from 3.03 to 3.3 grams per cc, which means the mantle has more heavier rocks compared to the earth's crust. That's why it is lower the earth's crust. And again, the mantle is divided into, we have the upper mantle and lower mantle. And the lower mantle. The upper mantle is very rigid. Very rigid, meaning that it bears some characteristics which are similar to those of the earth's crust. And that's why the upper mantle in the crust in combination called the lithosphere. Why? Because some characteristics of the upper mantle are similar to some characteristics of the earth's crust. But below the upper mantle, below this one, we have another layer we call asthenosphere. Asthenosphere. Actually, this is a very ductile layer. A layer that is there to absorb the shocks. The layer that is there to bring the isostatic readjustment. The layer that is not brittle. Dear student, the mantle is separated from the earth's crust by the zone of demarcation called the mantle is separated from the crust by the zone called Mohorovicic discontinuity, or simply Moho. But the name is not all of a sudden here. The name is derived from a Yugoslavian seismologist known as Dr. Andrija Mohorovic. So it means when we speak about seismology, this is a study of earthquakes. So it is the very person that made it travel and studied about the Earth's internal structure, the crust, the mantle, and finally he came up with the zone of separation known as Mohorovicic. Therefore, it bears its name from the launcher, from the school of thought that inaugurated the name. When did he do this? This was established in 1809. So this is when now the zone of separation between the mantle and the crust was established by this doctor from Yugoslavia, Andrija Mohorovic. Now from there, my dear student, we are done with the crust, we are done with the mantle. Finally, we go to the last layer, the last internal layer of the earth, that is the core. The core, in other words, barysphere. Barysphere. This core has the diameter of about 6900 kilometers, and it is separated from the mantle by the zone called Gutenberg discontinuity. This is separated from the mantle by the zone called Gutenberg discontinuity. This Guten actually is a person known as B. Gutenberg, and he established this in 1914. And therefore, from the mantle to the crust, we have the Mohorovic discontinuity. And from the core now to the mantle, the area of separation is just called Gutenberg discontinuity, discovered in 1914. Therefore, the name Guten, this is a person, this is a scholar of thought also who established the idea. The core is under high pressure. Is under high pressure with the average density of about 12 grams per cc. And the core that we have actually is also divided, the core is also divided into outer core and inner core. The outer core is liquid. Is liquid in nature, and the temperature is about 3700 degrees centigrade. Imagine, for water to change its state from liquid to vapor, it requires 100 degrees centigrade. Now, how hot is it with 3700 degrees centigrade? Therefore, the core is very hot. It's very hot. And it consists of nickel and iron, briefly known as Nife. Therefore, these are the main components of the core. The rocks that are making the core, the minerals are nickel and iron. And therefore, it is estimated to be to be 0 kilometers deep. These are the dimensions of the outer core. And therefore, from the outer core, we move to the inner core. This inner core, which is thought to be solid. To be solid because of high pressure. Because of high pressure. Therefore, the outer core is aqueous, is liquid, but the inner core is thought to be liquid because of the high pressure that is compressing it, and therefore the density, its density is about 16 to 17 grams per cc. The temperature of the outer core, the inner core, the temperature of the inner core is estimated to 5500 degrees centigrade. And therefore, compared to this one, this is extremely very hot, extremely very hot. My dear student, we have been able to go through the main layers of the atmosphere, the main layers of the Earth's internal structure. That we have seen, we have the crust. The crust has upper and lower. That is made of soil, is made of seam. We have gone to the mantle. We have seen the zone of separation. And again, we have discussed the core. That is the outer core and the lower core with all their characteristics. Now let us see generally the diagram of the Earth's internal structure. Dear student, let us now wind up by seeing the diagram that explains in general the Earth's internal structure. So this one here refers to the inner core. This one is the outer core. Outer core. And this one here, this is the Gutenberg discontinuity. And then we have the mantle here. The mantle. We have the Moholovicic discontinuity here. Moholovicic discontinuity. And on this part, we have the sile, that is silica and aluminium. And on this part, we have the simmer, that is silica and magnesium. And here, because this is the Roland here, this is what we can see. This is the hydrosphere. Hydrosphere. The body of water, lakes, oceans, and so forth. And therefore, having seen this, we are now aware that internally we have different layers from where we live on the Earth's surface to the core of the Earth. There are 3 layers, each layer with different characteristics based on temperature and chemical composition. Now, as we wind up this topic, my dear student, let us get the activity that will be reflecting what we have been discussing. Explain the main parts of the Earth's internal layers. Internal layers. The second activity, what do you understand by 1, Moholovicic discontinuity, 2, Gutenberg discontinuity, 3, sile, and 4, simmer, and the 5th, Nife. Having seen all this, my dear student, this marks the end of the first topic of physical geography of Form 5. That was position, behavior, and the structure of the Earth. Always feel interested. Don't miss my session. This has been part of my introductory topic. Next time, next lesson, we will move to the second topic of physical geography. That will be the dynamic Earth and its consequences. Having seen the Earth internally and externally now, we will see how dynamic it is. Thank you for watching. Stay with us. Never miss the lesson. This is the Elimika program.